Okay, we're going to try to get back on track with taking notes at home. You have a note sheet that you should have picked up from the classroom today that has all kinds of notes that we're going to cut out and glue in our notebook. So you're going to need your notes sheet from class today. Our title is Logic. Our date is 9/16/13. Alright, the questions we're going to answer today. We will learn what conditions make statements true and what conditions make them false. Turn this into your essential question. It goes under your title and date in your Cornell notes. Why do we need to know this? Because computers use logic, Venn diagrams use logic, and you're going to use logic in your life. Here's your do now. Solve the equation for x and find the values of the angles. Pause the video and work through those now. Alright, a statement is true if it is true for every single case. And a statement is false if it is false at least once. So it only has to be false once for the entire statement to be false. And it's true if it's true for every case. You need to write these down in your notes. See our pencil? A counterexample is an example that contradicts a statement. Contradicts means makes it untrue, proves the statement untrue. Quantifiers such as some, all, or none can be used to change the truth value. Alright, so let's look at this truth table here. This is an AND truth table. Okay, so the statements, Jack went up the hill, Jill went up the hill, and this is Jack went up the hill and Jill went up the hill. So when Jack goes up the hill is true, so Jack did go up the hill and Jill went up the hill, then Jack went up the hill and Jill went up the hill is true. If Jack went up the hill is true and Jill went up the hill is false, then the statement Jack went up the hill and Jill went up the hill is false. Jack went up the hill is false, Jill went up the hill is true. That makes the AND statement, Jack went up the hill and Jill went up the hill, false. So if Jack does not go up the hill and Jill does not go up the hill, then the statement Jack went up the hill and Jill went up the hill is false. So out of the 4 possible cases, which ones were true? Answer that in your notes. Out of the 4 possible cases, which ones were false? So looking at this chart, what has to happen for true to be the outcome and what has to happen for false to be the outcome? Answer those 4 questions in your notes. Alright, now we're going to look at an OR statement instead of AND. So this is Jack went up the hill or Jill went up the hill. So when Jack goes up the hill and Jill goes up the hill, the truth statement Jack went up the hill or Jill went up the hill is true. If Jack goes up the hill but Jill does not go up the hill, Jack went up the hill or Jill went up the hill is still true. If Jack does not go up the hill but Jill goes up the hill, this statement, the OR statement, is still true. But if neither one go up the hill, then the OR statement is false. So out of the 4 possible cases, which ones were true? Out of the 4 possible cases, which ones were false? What has to happen for true to be the outcome and what has to happen for false to be the outcome. These tables are on your note sheet. This one and the one before for you to write on and glue into your notes, and then you'll just answer the questions right underneath those. Alright, this is not on your note sheet, so you will need to write this out. A blank statement is true when both statements are true. This is an AND statement. A blank statement is false when at least one statement is false. So an AND statement is false if both statements are false. This one could be, the first one is AND or. Both of those are true when both statements are true. A blank statement is true when one of the statements or both are true. That's OR. A blank statement is false when neither statement is true. That's an or statement. Sorry, the pen quit working. That's an or and an and. Both of those are false when neither statement is true. If both of the statements are false, then the statement is false. And we call the truth tables the little table that we filled out. So truth tables can be used to summarize conditions that make and or statements true or false. Alright, so here's our truth tables. P is true, so P would be, in our instance, Jack went up the hill. Jack went up the hill. And our Q is Jill went up the hill. So true, true, and statement is true. All the rest of the time, if there's one false, then an and statement is false. An or statement is true when at least one is true. Here's a true, here's a true, here's a true. Those are all true because only one has to be true. And then it's false when both are false. Alright, Venn diagrams. Notice this set B overlaps set C in a region labeled D. So what types of things do we see in set B? What types of things are in set C? I'll give you an example. In set B are birds that don't fly. For example, a chicken or a penguin would go here. And things that fly go in set C, but they can't be birds. So a fly, a mosquito. And in the middle in set D, that is the thing that is a bird and flies. So a robin, a blue jay. Okay, so this is our and section. Right here, this is our and. Set of birds and they fly. So that has to be both things. The other two sides are just things that are birds that don't fly, or flying things that aren't birds. So recall your counter example, birds fly. We picked chicken and penguin. I'm going to make a new bird. Use the Venn diagram above to write a true statement using the word some. So some birds do what? Some birds fly. They don't all fly. Alright, so humans are insects. Notice there is no overlap here. Nothing overlaps. So that means that there are no humans that are insects, and there's no insects that are humans. Nothing fits into the and section of these two sets. Nothing is a human and an insect. So that means there's lots of counterexamples. Okay? Insects are said to be mutually exclusive because they have nothing in common. There's nothing in common between humans or insects. So if we were to write a true statement using the Venn diagram, I could write no humans or insects. Alright, now looking at this one, notice this set here, geometry, is completely included in mathematics. That means all geometry is mathematics. All of it, not just part of it. Nothing fits just in geometry but not in mathematics. So what types of things are in set B that are not in set C? So we want to know what types of things are mathematics but are not geometry. That could be algebra. That could be statistics. Those things would go in this section that are not geometry but they are mathematics. Alright, now let's go back to Jack and Jill going up the hill. It says, which parts of the Venn diagram depict when this statement is true? When the and statement is true is just when both parts are true. So how we know in terms of the Venn diagram is it's the part that overlaps in our two Venn diagram circles. That's our and part. So the part that says when the statement is false is when just Jack goes up the hill or just when Jill goes up the hill. And that's not homework. We'll do that in class tomorrow.